Greetings and welcome to using the TI-84 Plus. I'm your presenter, Lynn Mann. We'll be running through the Binomial Pdf function and the Binomial Cdf function. For the TI-84 Plus, working with binomial distribution, we do have two functions that we will use. The first one is called Binomial Pdf, Probability Distribution Function. The second is Binomial Cumulative Distribution Function, which is CDF. The difference is when you are going to use them. When you have something like the probability that x equals 2, that x equals is exactly 2, then you would use PDF. If you are in a situation that the probability you're looking for is x is less than or equal a value, like probability that x is less than or equal to 10, then you will use CDF. And if you're looking to answer a question that your value is the probability that x is greater than a value, then what you're going to have to do is a little bit of math on top of the CDF. The CDF only takes care of less than or equal to. We're looking for greater than or equal to. But the cool thing about it is we know all probabilities add up to 1. So if we do 1 minus the probability that x is less than that value, then we're going to get the right answer. So if it's equal, you use PDF. If it's less than or equal to, you use CDF. And if it's greater than or equal to, then you're going to use 1 minus the CDF. So let's see it in action. We have an example going on, and we want to find the probability that exactly 4 of our selected people have a high school diploma but do not pursue any further education. Our N is 20, our P is 0.14, and our x value is 4. Because of that, we're going to use PDF. So second, vars, which is the distribution right up here. And there's a whole long list of them to choose from, and you're going to find the one that's the Binomial PDF. Right underneath it is CDF. We're looking for PDF, which is an A. If you remember, A goes along with PDF, B goes along with CDF. I'll show you a shortcut way of getting there. So we want A. Our number of trials is 20. Our p-value is 0.41. And our x value was 4. We paste it to our screen and we hit enter for it to calculate. So the binomial probability is for that x is exactly 4 is 0.295. Now you might be wondering, hey, how is your decimal only showing up with 4 places? Well, that's because I actually put that setting on. So if you go to mode and you change your float value, the float tells you how many decimals you want. If you want your decimals to be rounded to the 4th place, just put it on 4. And that should do it for you. Okay. So let me get out of here. Let's go back to our problem set. So that was when it was exactly 4, I used PDF. Now what's the probability at most 12 of them have a high school diploma but do not pursue any education? So at most means that it could have been 0, it could have been 1, could have been 2, could have been 3, could have been 4, could have been 5, could have been 6, could have been 7, could have been 8, could have been 9, could have been 10, could have been 11, could have been 12. If we use PDF, we're going to have to calculate 12 of those and add them all up. We don't want to do that. We want the computer to do a lot of work for us. So this is CDS. So the binomial distribution function, if you say it's cumulative, it's going to take from 0 to that value and add them all up. So second, vars, and I said there was a shortcut way of getting down there versus toggle down, 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 down. It is alpha B. Here's B right here. So alpha B, and that will get you to binomial CDF. Trials is 20. Our probability that it's a success, our p-value is 0.41. And our x value is less than or equal to 12, so it's 12. And therefore, 0.9738 is our probability that at most 12 of them would have high school diploma but no further education. So let's find the probability that at least 15 of them have a high school diploma but do not pursue any education. So if I straight off use the binomial cumulative distribution function, so second distribution, alpha b, and changed our value to 15, we would get 0.9996, but that would be less than or equal to 15. So I'm looking for more than or equal to 15. So I have to say 1 minus this binomial CDF value, 0.9996. And that gives us 4 to the negative 4. In other words, 0.0004. Okay, 1 minus that. Make sure when your answer has this e value, that's in scientific notation, you got to move your decimal 4 places. So it's 0.004. Now, if I did not want to do that in 2 different steps, I could have automatically said 1 minus the binomial distribution. There we go. And that makes it do it in 1 step. Now it gives us some more decimals here, but remember we're moving the decimal places 4 spots, 1, 2, 3, 4, and therefore your answer would be 0.12344315, rounding to 4 decimal places, so 0.0004. So that's it for using your TI-84 plus for the binomial distribution. Just as a reminder, if it is x equals a value, you'd use Binomial PDF. If it is less than or equal to a value, then you'd use Binomial CDF. And if your value is x is greater than or equal to some number, then you would use 1 minus Binomial CDF. And that's it for now. Until next time, be seeing you.